Okay, so this is all about quadratics. In this box here are different forms that I could type the quadratic equation in. Okay, I'm not going to get too into that because we'll break them apart one at a time. So here's some key things about a quadratic. So a vertex is either the minimum or the maximum. So this or that. This is called a vertex. Depending on what your shape looks like, the vertex is either right on the bottom or right on the top. Okay, and this shape is called a parabola. I don't think I even wrote that down. Okay, so this shape is called a parabola. That's just the name of it. Okay, the root, the zero, or the x-intercept, those words, those three words, they all mean the same thing. And it's where you're crossing the x-axis. So we just did this. So this is what I'm talking about. Those points are called a root. In your calculator, they're called a zero, or we can call them the x-intercepts. Okay, the axis of symmetry. The axis of symmetry is a mirror line that, like, if you were to cut it like a sandwich and fold it in half, that would be where you could fold it symmetrically. Okay, and each point will have a partner. For instance, do you see that those points would kind of mirror each other? Okay, every point will have a partner except the vertex. The vertex does not have a partner. Okay, the slope A tells us some things. So here's the A. A is this number that we're always going to multiply in front. So it's going to tell us, does the graph open up or down? It's going to tell us, is this a wider shape or a skinnier shape? It's going to tell us those things. Okay, the domain is all of the possible x values. So when we write x, we talk about how far left to how far right do we get to go. How far left to how far right. Okay, so this graph specifically below us here, how far left does it keep moving? Well, this arrow means it's going, 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 going. So in a math sense, it's going left. So I'm going to go negative infinity. That means it's going left. To how far right do we go? So on this graph, it's just going to keep going, 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 going. So I'm going to go comma positive infinity. So it goes from negative infinity to positive infinity. Okay, the range is all the possible y values. So we're going to have to write what's the low to the high. What's the lowest to the highest? Okay, so this graph specifically, what's the lowest height? -4 is the lowest this goes. And I'm going to put a square bracket around it because it's exactly -4 to the highest height. So how high does this go? Well, these arrows mean it's going up, 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 up. So yes, you said infinity. And do you notice how my bracket is what we call a soft bracket versus a hard bracket? That just means exactly when I have a hard one. Okay. Okay, so we have already done some of this. So we had our TI-83s going. Okay, so we're going to graph y equals x squared. So I just did a clear and then I put the x squared in there. I think I'm still on my original grid. I'm just going to check here. Zoom 6. Everyone still looks like that? Okay, so I'm just going to draw a little sketch here. That's what y equals x squared looks like. Just a really rough sketch of what it looks like. Okay, y equals -x squared. So -x squared. Okay, remember the negative is I call it the baby negative. Not the subtract, but the baby negative at the bottom. Graph. Do you have a visual that looks like that? Is that what your graph looks like? Okay, and there's arrows on ours. Okay, obviously this calculator doesn't put arrows on them. Okay, so A is the number that's in front of the x squared. So technically, what number is in front here? How many x squareds do we have on this one? We have 1. We have 1x squared. So here, A is 1. And here, what's the multiplying number on that one? How many x squareds do I have here? Now I have a -1. So can we make a conclusion about what's going to happen? If your multiplier number, which is A, if it's positive, then what? We're going to open upward. And if A is a negative number, then what's going to happen? You're going to open downward. So if there's a positive multiplier, you're going to look something like that. If it's negative, you're going to look like that. Okay, let's go to this box next. Okay, so tell me, typing this in, y equals 3x squared. Everyone's got that in? Okay, I graph it. And that's what it looks like. If you want to see me compare it to the original, I'm going to put my original on as well. So I can go to y2, and here's my original, by the way. So in my y2, that was the original. So this is the original, and then this was the 3x squared. So do you see a difference? Okay. Got how it looks? Do you want to leave it on there and we can graph our other one? So y equals, go to this one, go down, the down arrow. Okay, you're going to go bracket 1/2. So do you see a bracket? Bracket 1 divided by 2 bracket. Bracket 1 divided by 2 bracket x squared. Everyone's good with how that looks on their screen? That looks the same? Good. Graph, what do you think happens? That kind of, to me, was what was going on. I might be over-exaggerating here, but okay, so let's fill this out on the bottom here. If the A number, so A was the 3, if it is bigger than 1, then what's going to happen? It's going to narrow. Do you see how it got, the arms of it went in? It went narrow. And if A is less than 1, so 1/2, right? A half is smaller than 1. Then what happened? It got wider. So if A is bigger than 1, it's going to go skinny. If it's a fraction or a decimal, it's going to go wider. Okay, let's go to this box. So y equals, I'm going to clear. Okay, we have x squared minus 3. X squared minus, so this is where you have to push the subtract button. The blue subtract button on the 3, okay? Graph, what do you think happened there? In a word sense, this would have moved down 3, right? Does that make sense? It moved down 3. Without our calculator, do we want to think about what would happen here? What do you just think? Which direction would this head? If this went down 3, this is probably going to go up 4. Do you think it will look like this? Do you want to graph it to see? We can just change the subtract 3 to an add 4. Graph, and looks like our prediction was right. Okay, so let's make a conclusion statement at the bottom here. This is the bottom, the 4th sentence. If you have x squared plus a number, it will move up. If you have x squared subtract a number, it will move down. Okay, last section here. Now I have to have brackets. So y equals, and clear it out, bracket x subtract 2 squared. Okay, you have to have brackets on this. Everyone got their brackets in the right spots? X minus 2 is in brackets squared. Graph. Ooh, what happened there? Do you think? What do you think about how that moved? this is moving to the, actually moved to the right. So it moved right too. Okay, to me, this is opposite of my brain, because you saw subtract 2. Probably in math, if you think subtract, it probably should go left, but it actually moves it to the right. Okay, so what do you think this is going to do? What's our prediction? That's going to probably move left 3. So this is opposite. Okay, it's kind of something you're going to have to think about. So that's the prediction. And if you want to see if our prediction is true, you can go back to your y equals and change the subtract 2 to a plus 3. Graph, and there it is. Our prediction is true. It moved left 3. Okay, so we'll fill in the last sentence here. If you have a subtract inside, it moves right. And if you have an add inside the bracket, it will move left. And then I'm just going to write a reminder for myself. Hey, take note. That's opposite of what my brain wants to think about, right?